Hello everyone, my name is Shyam Manawat and I welcome all of you once again to the series of linear equations. We are in lecture number 9. In the previous lecture we have learned by plotting the equation of line on the xy plane and understood that whether the lines are intersecting. What are the intersecting lines called? The pair of equations will be called consistent, right? And if they are parallel, then inconsistent by using graph. Now in today's lecture we will learn by only taking the coefficient of x, coefficient of y and the constant term. So let's get started. So let's understand relationship between lines. So two lines, either they can intersect at a point, they could be parallel, or they could be overlapping, like a line on another line. Like both lines are following same path basically. Both lines are following same path. So these are three different conditions possible, relationship possible between two lines. Intersecting at a point, parallel, and the third condition we call it coincident. Now how do we learn, how do we understand? By only looking at the A1, A2, B1, B2 and C1, C2. What are A1, A2, B1, B2 and C1, C2? That we have understood in the previous lecture itself. Do you remember this? That's how we assume the first line and the second line. So the first line, which is A1x, what is A1? Coefficient of x. What is B1? The coefficient of y. And what is C1? The constant term. Similarly, for the second equation, we are taking all with the number 2. This is equation number 1 and this is equation number 2. So, if you relate them and if you say A1 upon A2 is not equal to B1 upon B2, then you will find the relationship between lines, they are intersecting. Okay, you can also say their slopes are not same. If A1 upon A2 is equal to B1 upon B2 and not equal to, this is important, not equal to C1 upon C2, then you say that these lines are not intersecting. They are parallel. They are parallel line. Their slopes are same. What is slope? Angle of line with respect to positive side of x. You can make a note there. The slope of line is what? Make a note here. Slope of line is angle of line with positive side of x-axis. The angle of line with positive side of x-axis. Yeah, that is slope. So slopes are same. Now the third condition is A1 upon A2 is equal to B1 upon B2, and that is equal to, all of them are equal. The ratio of all three values A1, A, B, C are equal. In that case we say the lines are what? Coincident. That means they are overlapping. That means both lines are following same path. Yeah, so make a note here. Make a note here. All right, done. So by using these relations, let's see how do you treat the equation of line and understand whether they are intersecting or not intersecting. Yes, so first line is this. Tell me what is A1 here? What is A1 here? 5. What is B1 here? Say with sign, -4 and C. Alright, so here we have +8 this side, no problem. What we can do is, you can shift to the other side also so that you are not confused, although it doesn't matter much, but better to look like standard equation. A1x equal plus b1y equal to c1. For that, the first equation, let me write it as 5x minus 4y equal to minus 8. Yeah. Here the second one is 7x. Yeah, that's a2x, the second equation, plus b2y equal to c2. And the second equation is 7x plus 6y equal to 9. Make them look alike. That means the variable at one side and the constant to the other side of equation. I am telling you, it will not make much of a difference. Even if you keep everything at the same side and the other side is 0, the way it is given here, you will still get the similar answer. You will still get the same answer, not similar, same answer. Yeah, same relation. But still, because we should standardize things, that's why we are writing it. Okay, we are keeping the steps in mind, the micro detailings in mind. Okay, so a1 is what? 5. a1 is 5 here. So if I want to check a1 upon a2, what will I do? a1 upon a2 is what? a1 is 5 and a2 is 7. So you got 5 upon 7, right? Similarly, if you want to check b1 upon b2, b1 upon b2. So b1 here is minus 4. Say which sign? Minus 4. And b2 here is what? Plus 6. So what is b1 upon b2? Minus 4 upon 6. Question: are they equal? a1 upon a2, is that equal to b1 upon b2? Are they equal? They are not equal. If they are not equal, we don't have to check c1 upon c2. No need. No need. Because when they are not equal, we directly say the lines are going to intersect at one point. The lines are what? The lines are what? The lines are consistent. Yeah, the pair of equation is consistent. The pair of equation is consistent. This pair of equation is what? Consistent, right? That means if you draw on the graph, plot on the graph, they will intersect at one point. Yeah. Okay. Let's quickly see the next equation. I hope you are comfortable now with a1, a2. What is a1 and a2? The first equation, it's a1, b1 and c1, and for the second equation it is a2, b2 and c2. As I said, whether the constant at the constant is towards the variable side or constant is the right hand side and variable at the left hand side, when you compare the ratio, it will not make any difference. You can do the way it is. If you want to make it similar to the standard one, you can do this way. Yeah, because sign is important. Sign is important. Now here you see, what do I do here? First, let me write 9x plus 3y equal to minus 12, and the second one is 18x plus 6y equal to minus 24. So they will look like what? a1x plus b1y equal to c1, the way we assume, and a2x plus b2y equal to c2. Now take the ratio. If you take the ratio, a1 9, a2 18. So a1 upon a2 is 9 upon 18. We are in concept builder video, so I am discussing the concept, the basic concept. Yeah, if you know this concept, you can skip this video and go to the next one. That is 1 by 2. If you look at, similarly, if you look at b1 upon b2, b1 upon b2, b1 3 plus 3 and b2 plus 6. Do you see here 1 upon 2? Yes. Now let's look at c1 upon c2. C1 upon C2, C1 upon C2. So C1 is constant, which is minus 12 here, and C2, which is constant again, minus 24. Minus minus cancel, this is also 1 upon 2. What is the condition? This condition is giving you A1 upon A2, which is 1 by 2, is equal to B1 upon B2, which is also 1 by 2, equal to C1 upon C2, that is also 1 by 2. Right? So all of them are equal. This condition, in this condition, we will say the lines are coincident. That means they are intersecting at each point. They are following the same path. Okay. Now in such case, when you solve the equation, linear equation, then what will happen? They are intersecting at all the points, right? They are overlapping. They are following the same path. They are overlapping. So, do you remember this point when two lines meet at one point, intersect at a point? Here, this point is common between the line 1 and line 2. Correct? That point, listen to this carefully. That point is called a common point between these two lines. That point is called solution of simultaneous equation. Solution of the pair of lines, pair of linear equations. Yeah. So when they intersect, when A1 upon A2 is not equal to B1 upon B2, they intersect, you will get a single value. Yeah. So here for this condition we say unique solution. For this linear equation has unique solution. Note this. Unique solution. The second condition, where the lines do not intersect, for that condition we call it no solution. Why no solution? They don't intersect. There is nothing common, no point common between them. So no solution. The simultaneous equation has no solution. The pair of linear equations has no solution. Yeah. When do they have no solution? When A1 upon A2 is equal to B1 upon B2. Lines are going to show same slope. Lines are not going to intersect. Lines are parallel, one of the same thing. All these three are same thing. Okay, same condition. No solution. And when the lines are coincident, that means following the same path, that means overlapping each other, we will say the system has many solutions. Many solutions. Note this. Yeah, note this part. I hope this is clear. Yeah. Condition number 1, condition number 2, condition number 3. When they intersect at a point, it's a unique solution. Unique solution, that means you will get one point which will be common point for line 1 and line 2. No solution, never intersect, no solution, no common point. Many solution in this case because lines are overlapping each other. Yeah. Lines are following the same path. So many solution, or sometimes it is also called infinite solution. Because all the points, they'll keep, every point will be common between them and we won't be able to count the number of points. So that's why it is infinite solution. This case is also called, third case is also called infinite solution. Noted? Good. Okay. Now see. So here, if you try to solve, you will find many solutions because A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. So the question could be, for these pair of lines, do they have unique solution? Answer is no. Are they intersecting? No. Yeah, are they parallel? No, they are the same. They are following the same path. They are intersecting. They are having many common solutions, many common points. That's why we say many solution. Yes, I hope this is clear. This is third case 3. Okay, so you can pause this video and then try solving these 3 questions and check whether lines are intersecting, lines are parallel, or lines are coincident. Or I can also make a question like, check which of the following has unique solution. I can make this question like this also. I can make question like this also. Which of the following is having unique solution? Or I can say which of the following are having no solution. Or I can say which of the following has many solutions. Yeah, all these 3 conditions you will be able to identify by comparing the ratio of A1 upon A2, B1 upon B2, C1 upon C2, and then see what is happening with them. Let's try with question number 3 quickly. Yes, let's try with that. Let me not take a lot of time here and directly write the first. For the first equation, you got A1, which is 6. Here B1 is what? 2. So 6 upon 2. B1, which is minus 3, and here B2, which is minus 1. Constant 10, and here constant 9. If you take it to the other side, it will be minus 10 and minus 9. So minus minus will get cancelled. One of the same thing. I kept explaining this. Yeah. Do you see? This is 3 by 1. This is also 3 by 1. So what do you have here? A1 upon A2 is equal to B1 upon B2. Let's quickly check with C1 upon C2 what's happening there. Let's check what's happening there. This is not 3 upon 1. Yeah, this is C1 upon C2. So not equal to C1 upon C2. That means only the slopes are same. Only the slopes are same for these 2 equations. Yeah. So we will say this equation doesn't have unique solution. It has what? Many solution. That's case of many, sorry, my bad. That's the case of no solution, because lines will be parallel. No solution. They will not intersect. No solutions. Yes. Or we can also say lines are parallel. Okay, great. Tell me about the fourth line, this fourth one. Tell me, what is the condition? A1 upon A2. A1 is 3, A2 is 2, B1 is 2, B2 is minus 3. Yeah, are they equal? 2 upon 3. Is it equal to minus 2 upon 3? No, not. Yeah, so we are saying what? A1 upon A2 is not equal to B1 upon B2. This is the first condition. First condition here. First condition. What do we say? Unique solution. So here we'll say the pair of linear equations will have, they have unique solution. When you solve, they will have unique solution. They will intersect at one point. Yeah, so we can also say lines intersecting. Lines are intersecting. One of the same thing, okay? One of the same thing. Yeah, we need to see what is the question about. If it is only about solution, we'll say unique solution. If it is about relationship between lines, we'll say they are intersecting lines. Okay, fine. Quickly tell me about the fifth one. A1 is what? The coefficient of x for the first equation. 2. A2, coefficient of x for the second equation. 4. B1, coefficient of y in the first equation. -3. B2, which is coefficient of y in the second equation. Yeah, B1 is -3, B2 is -6. C1, 8, the constant. C2, 9, the constant. Yes, this is what? 1 upon 2. This is also negative cancel. 1 upon 2, 8 upon 9. We can't simplify, we can't cancel this further. So what do you see here? A1 upon A2 is equal to B1 upon B2, which is not equal to C1 upon C2. Again, the lines will be called parallel. Here we will say pair of linear equations has no solution. Yeah, no solution. Or we can say lines are parallel. All right, great. Good. So I hope these three conditions are clear to you. And why are these three conditions? I hope that is also clear to you. Fine. So this is it in today's video. I will see you in the next video where we will solve questions, the exam questions on linear equations. So I will see you in the next video. Till then, stay happy, stay healthy. Bye bye.